Good evening. So in this video we'll show you how to get batteries for your solar system. What you wanna do is go to the dump, look for some nice big boys and get a car headlight about 55 watts, should be enough, and a multimeter, and check. Put the battery on put the load on the battery, measure the voltage. Let's say with these 150 amp cells it should be like, I don't know, about 1250. For these 100 amp ones, about, I don't know, 1240, but about 1250 it should hold the charge. Anyways, these all 8 batteries here were 600 euros. Just one of these 100 amp batteries is 400 euros, probably 300 euros actually each. So it's a bit of a gamble, definitely a risk, but no risk, no gain. What the main point of this video is this device that I have made from scratch. As you can see, it is a heater, it's a space heater. Used to have a fan and a heater right there. It is built around this PZM 015 module here, as you can see. Let me just focus on there. So this PZM 015 module gives you the voltage, current, wattage, watt hours, amp hours, external resistance, internal resistance, charging, running time rather, and state of charge. Now, what I've done here is this. As you can see, jumble of wires. I have a PWM that goes in here. So this is the PWM control. Bypass for the protection. It is in Macedonian because why not? It's 15 volts, 30 amps max. Due to the way the module is built, all the switching is done on the positive side, so the grounds are connected. Rather, no. One of the grounds goes to a shunt. It's a 50 amp shunt. I use some automotive relays for reverse polarity protection, and I use these two relays for also for protection. So the automotive relays are for these two, and then the MOSFETs are for these two. And of course there is a selector switch, top, 0 and bottom. There is no current regulation or anything like that. That does rely on you to just twist the knob. This device comes with this device as well, so as you can see, it's just it's 4 headlights put into a box, and it goes out to these leads. So you have about like 30 amps of load here, but put in some switches as well so that you can toggle on which light is on. Put in a fan, but the fan is too weak, so I use this other fan. This, as you can see, this tube right there, it's a fan. Other than that, oh yeah, and I added this voltage comparator circuit, this relay, so that when the voltage gets down to 10.8 volts, it cuts it off. It's got a potentiometer, so you can tune it. What else? It's powered by this LED power supply, it says, so 12 volts, 30 amps. It's got a potentiometer inside, so I've set this to 3 volts. So I can charge the batteries. As you can see, it's charging it at 14.2 due to some voltage drop in the MOSFET. It's about 0.1 volts, which is insignificant. PWM is run with a NE555. The comparator is coincidentally also an NE555, and so once it reaches 10.8 volts, switches on this thyristor. This thyristor latches on this relay. This relay cuts off the PWM signal. What else can I say? So batteries, the success of these batteries. These are 150 amp hour cells made by Hopeke. As you can see, Hopeke. Now you can see these are not that good. These are from 2015, commissioned in 2015. Oh well. For the price, 72 amp hours, I guess it's fine. But you just go according to the spec right here. So 10.8 volts at 15 amps constant current. It should run for 10 hours. So this one is 72, this one is 53, this one is 33, and this one is 55. Somewhat disappointing. On the other hand, these 100 amp hour cells or batteries, 3 of them are 80 amps. So 89, 80, 80, and 55. So this is the bad cell, and this is why they threw them out. But anyways, it'll do for my system combination. It'll do. What else can I say? I would have done this somewhat differently now. If I ever do a second version, probably won't. You know, so that you can have constant current and so on and so forth. But oh well, my battery is dying. But these the car headlights have quite sufficient stability in their current draw. So if for an example you want a 10 amps constant current, you just set it to 11, and once it gets down to 10.8 volts it draws 9, so 10 on average. It's good enough for the purposes here, what we're trying to achieve. Something cheap, something simple, something easily repairable. Other than that, if you do need schematics of this, I can give you the schematics, although it's not anything complicated. It's just literally an E555 PWM thing that can go from 0 to 100%. And that's it. Thank you for watching, and I will see you next time.